Hi, this is Miss Oliva, and this is 9.2. This is also solving systems with matrices. So for number one, this is a little more simple than what we've been doing, but notice that with a 0, 0 here, what this would really turn into is the top would be x plus 6y equals 4, but the bottom, 0x plus 0y, just means we'd have 0 equaling 3. Remember, we saw that before when we were doing substitution and elimination. That was one of the special cases that was either no solution or infinitely many solutions. So since 0 does not actually equal 3, this makes no sense. This is no solution. So this one would be no solution. And if they asked you, it's called inconsistent. Now, this one's very similar, except that bottom line would end up saying that 0 equals 0, which is true and would always be true. No matter what x and y are, since there are no x's, no y's, this will always be true. It doesn't matter what they are. So this is the special case that is infinitely many solutions. So for number 3, this is really x plus 5y equals 2, but then here it is y equals 0. So we actually have a value for y. So then we could go plug it in and get x plus 0 equals 2. So this one is one solution, and we know it. It is 2, 0. So these are the choices: no solution, one solution, and then you give it, or infinitely many solutions, which you can also write how to get the answer. And we'll show that when we get one of those. So number 4, here we go. This one, 0 equals 0, is true, always true. So this one is infinitely many solutions. But now we need to give it at least some form of the solution. We're not going to have a nice solution like 3, 4. But since we normally write the x and then the y, we can just say, well, y is going to be some number that we don't know. But the relationship between x and y, if I use that top equation and then solve for x, I will see, so you could write 2 minus 5y or negative 5y plus 2, same thing, is that's the relationship. Whatever my x is, I know it's going to be negative 5 times whatever the y is plus 2. So even though I don't know the actual numbers, I know how they relate. So for infinitely many solutions, that's how you'll write it out. You'll just say y for the y, but for the x, you'll figure out the relationship. And then finally, that last one, if I think about the last line, that means 0 equals 1, which does not make sense. So this is the one again that is no solution. So there's an example of each type. Next one says solve with Gaussian elimination or Gauss-Jordan elimination, which means the ones and the zeros. So even though we can do this another way, let's go ahead and practice this method to get a little more comfortable with it before we get to the harder ones in a minute. So what do I want first? I would like this to become a 1. Well, there's already 1 down here. So the first thing I'm going to do is I'm just going to switch these. So that made, whoops, make sure you switch everything. This should be 16. So that made that easy. This is fine. I definitely want this to be a 0. So I could easily multiply the top by negative 3 and add it to this to make that a 0. So that's what I'm going to do, which means I'm leaving the top as is because it's good to go. But in order to make that a 0, when it's a 3 right now, I'm going to multiply the top R1 by negative 3 and add it to R3. So this times negative 1 plus this would be 0. This times, times negative 3 would be negative 9. negative 9 plus 9 is also 0. I was not trying to make that happen, but it happened. So this is probably going to be one of the special cases. 3 times negative 3 is negative 9 plus 16 is 7. No. 25. To make sure I'm doing that right in my head. Okay. Yes. Is 25 minus 9 would be 16. So here's where we are. It really didn't matter what that number was as long as it's not a 0, because 0 equaling anything other than 0 does not work. So it is no solution, which is inconsistent. Okay, now for a harder one. And this one in the homework, they actually talk you through it step by step. So I tried to write it out the same way so you'd understand what they were doing. So first they give you the equations, and then I think they even give you it as a matrices. You didn't even have to do it. They're showing you that they're going to keep line 1 the same because it has the 1 that we need. But for line 2, what could we do to make that negative 2 become a 0? Well, they're kind of painting it out here. They're saying you could multiply R1 by something and add it to R2. So what would I have to multiply this by to add it to R2 and get a 0? Positive 2. So positive 2, I guess I'll just start writing that out so I don't forget what I'm multiplying by. 2 times 1 is 2, plus negative 2 is 0. 2 times negative 3 is negative 6, plus 7 is 1. 2 times 17 is 34, plus this is negative 4. 2 times negative 2 is negative 4, plus 6 is 2. And then for R3, so they're doing these both at the same time, they're trying to get this to be a 0 as well. So really, we could just subtract line 1 and line 3. But since they've already put that they want to add R1 and R3, then okay, let me just make this negative. So negative 1 is what I would choose to multiply R1 by. So it would become negative, and then when I add it, I'll get 0. So I'm now multiplying row 1 by negative 1. So this would become positive 3 plus negative 5 is negative 2. This would become negative 17. Negative 17 plus 25 would be 8. Let me make sure that's right. Yeah, that's right. And then positive 2 plus negative 1. So we've gotten this to be a 1. This is a 0 and this is a 1. This is a 0. We now need this to be a 0 and we're good. So they're keeping row 2 the same. They're doing something with row 1, even though I don't think we really need to. But let's go ahead and say, what could we multiply R2 by? I guess they're trying to make that a 0. So you could multiply R2 by 3, because that would make this 3, and add it to get a 0. So 3 times 0 is 0, plus 1 is still 1. 3 plus this is 0. 3 times negative 4 is negative 12, plus 17. And 3 times 2 is 6, plus negative 2 is 4. And so what could we multiply R2 by and add it to R3 to get that second 0? Well, R2 is this. So if I want to get a 0, I would like that to be a 2. So I'm going to multiply R2 by 2 and add it to R3. So 0 and 0 is still good. This becomes a 2, which gives me my 0. This becomes a negative 8 plus 8 didn't need that, but that means it's going to be one of the special cases. And 2 times 2 is 4, plus 1 is 5. So there's a contradiction, which is what they call something like this, right? So we know it's going to be no solution. But first, they're just asking us to write out what this new thing means. So it means x plus 5z would equal 4. Y minus 4z would equal 2. And 0 would equal 5. Okay, so now that we have this, like we already knew, there's a contradiction. This doesn't make sense. So that means the system is inconsistent, has no solution. And so the solution set, if you had to write one, would just be this, the empty set, meaning just do the braces with nothing in the middle because there is no solution. Oh, and I think that's it. So when there's 3 rows, it definitely is tricky and takes some practice. But if you try 1 or 2 of the ones I've done here kind of on your own and see if you're starting to get the hang of it, then you should be able to do the homework just fine. Let me know if you have any questions as you go through it.